cookie jar is moving up a 40-degree incline.
A cookie jar.
Yeah, it doesn't give you math.
Okay, so number 56.
At a point 55 centimeters from the bottom of the incline. So now we're up here. And this is 0.55 meters. The jar has a speed of 1.4 meters per second.
Okay. Wait, and that's at this point?
Yep. Okay.
So it's not a constant speed?
The coefficient of kinetic friction between the jar and the incline is 0.15.
Okay. U thingy.
How much farther up from the incline will the jar move?
Okay. Because so it's decelerating and
So we want to see how much farther up from the incline. Okay, so you set it. It's Ki, right? Plus Ui equals what?
equals K final plus U initial plus change in energy.
Plus U final.
Or U final is I meant plus change in energy.
The Ki is 0.
Yes. And so.
Oh no, your K is not. You're starting from here.
Okay, yeah. Yeah, Ki, that's gonna be 1/2 or 1/2.
It's important that you know you're starting here.
Oh, you're starting there?
Yeah. How much further up? So we're gonna say this is our new.
Yeah. Okay, that's
So 1/2.
1/2 mv squared.
So what's your RV?
Is 1.4. U initial, we're gonna say 0.
Yes, because we're starting from here.
Because
So
and it's asking how much further.
yeah. So there's potential energy from here to here, but we're saying
It doesn't
this is our
matter.
ground. Yeah. It's all relative.
Plus 0.
Equals.
K final is gonna be 0.
You guys are under control, obviously.
Yep.
Yeah.
You have Andrew, so.
Yeah. He's good.
Plus, what's
U final. Well, actually, we don't. Yeah, it's gonna be MGH. We don't. So we don't know what it's gonna be.
and we don't know what height is. Plus, what is friction? What's the? How do you get the
Friction.
energy from friction?
Oh.
It's force of friction times distance, right?
Yes.
Oh, really?
Equals your force of friction times your distance. Okay. But yeah. We only want to have one variable, so we have to change this in terms of h. Okay,
Change this in terms of h.
Yeah. So, well, what's friction equal to? Force of friction.
It's gonna be mass. Well, no, that just.
You should know what force of friction is.
UN?
Yeah.
Oh.
This equals
Yeah, that was from
mu
last chapter.
N. Okay, and if this is always going to be 40 degrees, right? And this is our distance, and this is our height. So you have to put distance in terms of h.
Okay.
It's going to be a trig problem. Yeah. So what do you be?
Well, you can. This is our d, right? That x is d.
So we're going to say
So sine of 40 is h divided by d.
h over d.
So d is equal to h sine 40.
Well, you switch them.
Alright, sorry.
D is equal to h divided by sine 40.
Yeah.
Okay. What is our normal force? You can figure this out. You have to do it with your buddy out here. This is a long problem. See how far it is.
So this is normal force. We have mg
40 degrees.
Depends on the grade.
Okay. So what's your y component of gravity?
is going to be cos. What?
You keep your mg.
Yeah, mg cosine 40, I think.
Yeah.
Yeah. And
Okay.
yeah.
So we're gonna say it's 9.8 m, right?
Yeah.
Cosine 40.
And that's the normal force. Or no. It's not the normal.
That's
yeah,
normal.
that's normal force.
So it's friction. That
So
times-
friction is this times mu times
So then this becomes our force of friction is mu times 9.8 times m times cosine 40 times distance. What's the distance?
is h divided by sine 40.
Okay, that's our equation.
I'm gonna write that down.
Well, so
Okay.
we have two variables and we have to eliminate
I mean,
one.
there was like beginning duets.
Is there something in common on both that we can?
Yeah, m.
Okay,
You
so
can divide m. I
and
divide
each-
everything by
each
m.
term has an m, so we can.
So okay. So now we only have h's.
Okay, so what's your? You can figure this out.
Yeah, it's just gonna be a constant.
Well, that's.
Everyone's in that.
Can you take the bus?
No, I've tried. I'll be fine.
So we can say friction.
Yeah.
Underwrite. Okay, so this is equal to 0.9 on this side.
Okay.
Okay. And this is equal to, we're going to say G is 9.8 H.
Yeah.
Okay. And this is equal to, you can do this. Sorry, plus.
Yeah, plus. Wait,
U
we
is
don't.
0.15.
Okay, we do know that. 0.15
Times 9.8
times 9.8
times cosine 40
times cosine 40
divided by sine 40.
divided by sine 40,
I really wanted to see it. Wow.
and that's equal to 1.75.
Everything's well done.
75 what? There's a variable still there.
Oh, H.
Okay. And now you can solve for H.
Sweet.
What happened to your mu here?
The mu, it was given to us.
Oh, okay.
Right? Yeah. Okay. Yeah.
So this solve for H real quick.
Okay. 0.98 equals 9.8 x plus 1.75 x for x. 0.08.
Okay, so H equals 0. What?
0.085.
0.085.
Probably, I think it's something that
Okay, so that means that this is 0.
Oh yeah, we're not done yet.
because then you can get all
So then we have to solve for this.
But that's just just sine is that, and so that would be 0.0 what is 85 divided by 740, right?
I guess they make one every year.
0.13
So like we had that book with us that
meters, I
had
guess.
and like the track.
So that's how much further it goes up. That's the one part. And then
This part A.
there's actually like 3 parts.
Oh wow, this is a tough one. I'm gonna make sure I do this.
How fast will it be going when it has slid down to the bottom of the incline?
But one of the things
So it goes up. Okay, so you just do this again.
Yep, so we're going to do the same.
Yeah.
So here, you write it this time.
Okay.
So you have KA plus UR.
Okay. Oh, sorry.
Sorry.
Plus UR equals KF.
Plus UF plus change in E.
Yep.
Okay. Your KI is 0 because it's at the top it is 0 velocity.
And this is MGH.
So your H is this height plus that.
Which is just gonna be that times 2, right? Oh no, it's not.
You have to solve for this H. This is 0.55, remember?
Yeah.
This is 40 degrees. This is your height 1, and then this is your height 2. So your total
Oh,
height.
but we can figure it out because we know this now.
What do you mean?
Or
We
you
know,
just
we know
decide.
this. We can,
Yeah.
because this is
Just
that.
like a triangle. Make it a
And
big
so it's just,
triangle.
it's gonna be, we can figure this
You can
out.
figure out a bunch of ways.
Just trick, like,
Yeah, inverse sign.
yeah. Inverse sign. Or yeah, hold on. If I just do 0.55 plus 0.1, is it 1.5? No, 1.3. Okay. Times.
We're doing a lot of rounding, so your answer might be slightly different.
Yeah, I had it as my
I think it's gonna be like.
Did you add those two and you found so you
Yeah,
found the
I
total
think
height?
I think the total height's gonna be about 0.44.
I wanted to do it at his retirement.
Keep going.
Okay. K final is gonna be 0.
No.
Or no, that's what we're trying to find.
Yeah.
Which is 1/2 mv squared. Okay. And this is gonna be 0. And change in energy.
It's gonna be the same thing that you do. U times 9.8.
Did we get an answer for that? Did we just? Well, the
H is gonna be different there, remember?
but we know what H is.
Yeah, so you're gonna plug in H.
So let's just plug it in and figure out what the constant is.
Okay, so 1.5 times 9.8 times cosine 40
Cosine 40
times the total height
times.
That's really cool. I like that.
divided by sine 40.
Divided by
It's simple but fun.
Because, well, well, you would be able to cancel it.
Yes.
Just so you know.
Yeah. 7.
You were doing really well this time.
Okay.
And now we know G, so and we know H. Yeah, we're left with just velocity. Okay. Oh, cool. Not too bad. If you think about it.
Michael, can you guys grab all those paper cups and move the trash, please?
Andrew, you were extremely helpful.
Yes, thank you.
Thank you. Have you been recording? Can you post it on Facebook?
It would be
I don't know if you can watch
spring.
it.
Okay. Yeah, so
try.
when do you use Hooke's law as opposed to?
There's one problem.
Well, Alex, we'll see what happens tomorrow.
I don't remember how much weight.
We'll see what happens
That would be
tomorrow
how
when
far
they
does it
send this
compress?
out
That
of
would
the
be Hooke's law.
TSSAs early.
Yeah,
Be positive it sure isn't going to take much more than the 8
So
block.
if this is like 10 kilograms, the force would be low.
Well, Emma, how do you know what the
Tell me you need to get done there, man.
How much force is it putting in?
It's 10 kilograms? kilograms?
If this is 10 kilograms,
See
how
ya.
much force?
Thanks for drinking the pie. Bye, everybody.
Put it in the spring.
You don't know
We'll
kinetic
see ya
acceleration.
Friday,
That doesn't
probably,
matter.
if
What
not
is-
sooner. See ya.
What's the only force acting?
Gravity,
right?
gravity. Oh, and the so the acceleration is
All right,
9.8.
Chris.
Oh, so it'd be
Forget about
98.
that.
Yeah, so
Yep.
90 equals negative. And then
And
if
you
have to
be
give
given.
Oh, you know
So
what,
yeah,
though?
and then you
okay,
can
you'd
solve
be able to
this.
figure it out.
Yeah.
I'm proctoring.
Now, so that's Hooke's law, but then when would you
The room will
use
be open. If there's no teacher in here, you can come in here.
the work is
Or
1/2
if
kx
there's
squared?
something else you can do
So then, but then let's say if there's something that
something
drops,
But I don't
now it's
think-
dropping
I
on
don't know
here,
if
right?
teachers in here.
Yeah.
Okay.
If not, it's yours.
First you have to find
Yeah,
what its
yeah.
velocity
Thanks.
will be when it hits the spring.
Okay.
You know how to find that, right? That's your basic.
It's like 1D equation.
Yeah. So then once you find velocity from that, when it falls that distance, okay, so then it's going to compress
Some x
this
value.
distance. So it would be Ki is the velocity that it starts with.
Wait, hold on. What would we be trying to find?
The amount that it compresses.
Okay.
Ki is the velocity that it hits there, right?
Okay.
Plus Ui. Now what's Ui though?
UI, is that going to be up here or is that here?
That's starting from here.
Starting from here. Okay, it's going to be right there.
So-
That's MGH.
Well, what's your h in this case?
X. So MGX.
Equals, and then it's going to have a 0.
For kinetic final, it's going to be 0.
Yeah, but and then what's potential energy at the bottom?
This is going to be 0.
No.
No, MGX.
It's all being compressed in the spring.
1/2 kx squared.
Yeah.
That's the potential?
Yeah.
How is that potential
Because
energy?
when it's compressing, there's all that energy is being stored in the spring.
Hey.
But
So then why, for the
Oh, I
first
forgot
problem,
it's the end.
for that first problem, why wouldn't it be 1/2
It's
kx
very
squared?
I
confusing.
don't know, it just is. That's the best I can tell
So
you.
the difference is when it's something dropping onto it?
Yeah.
That's the difference?
Yeah.
So you changed
Yeah, you
the
definitely need to put like weights.
kinetic
on
energy
top of that.
formula
Otherwise
to-
So
you-
let's say it was
Right.
started at 15 meters per second.
Oh yeah, not a problem.
Yeah.
So that'd be
Try to
1/2.
download that software tonight. So you
And
find out
it's
if
10
you can
kilograms
get it,
on it.
Otherwise, we'll have
10
to come up with some
times
alternate plan.
15
I
squared
think they let you download the
plus
sample.
10
Alright.
times
Yeah.
9.8.
Oh, you know what? If
I'm just
not,
making this up.
Yeah.
X
I have a disc
equals
somewhere
1/2.
that has at least an older version.
And let's say
of it
K
that'll
is
work. If you can't do it, let me know.
500.
We'll find it.
Okay.
All right, see
500
ya.
x squared. And then you have a quadratic here that you probably have to use your calculator to solve.
Yeah.
Negative b plus or minus the square root of b squared over 4ac,
All
right?
over 2A.
Yeah,
That's
over 2A,
quadratic
yeah.
formula.
I just made this up completely.
Yeah.
So wait, why is it again that the 1/2 kx squared is that formula for potential energy instead of UGH?
Because then all the potential energy is stored in the spring then.
Oh right, okay, that's the spring formula.
Yeah. And then if you know all those, then you should be plenty good.
Okay, so if it's something dropping onto a spring, you have to do the x squared, and if not, it's just basic Hooke's law.
Yeah.
Got it.
I don't know why, and that's the best I can do.
Mr. Jonathan, can you explain that? Like, do you know why?
I didn't hear you.
With stuff with springs, like you only use Hooke's law if it's something like resting on a spring, but then otherwise.
You're only using Hooke's law if you're trying to find the spring constant, or if you have the spring constant, you're trying to find the force. It
Okay.
does not work with. It does not work with the potential energy equation. You don't
So
get the correct K
you
value.
can't use Hooke's law in the energy equals K final minus K initial, like. I think.
No, because how would you use that? You could
Yeah.
use it, but you have to use it as the integral of
Which is the
f
which
of
is
x
the
dx,
1/2
which is
kx
already
squared.
the 1/2
Oh,
k
okay,
squared.
so they
yeah.
are related. Okay.
Yeah, unless you, which I won't give you, but unless you're given a spring with a different, something different than f equals kx, it follows a different. It follows a different.
Certain springs follow different equations.
Could be.
What?
Could be. So you might get something like that on the AP test.
How
What?
could, I thought
Are
it
we
was
gonna?
like a constant, like as a
Right,
law.
but there are some that don't follow Hooke's law that are not non-standard springs.
What? We're gonna learn about that?
No.
No.
Well, you did. You got integral of f of x dx.
Here,
You
this is
have
the
to
one
know how
that
to
you
do
use.
integral of f of x dx. So you'd be given the function,
Right.
you'd have to put that function in.
Let's say Hooke's law.
Right. Okay. Yeah, I
Yeah.
got it. Okay, makes sense.
Okay, I got it. Yeah.
Sorry, use Hooke's law when